Graphs now. They're the graphs of horizontal or vertical lines. If we were going to graph y equals 3, you notice we only have one variable here. So that means no matter what x is, no matter which way we travel on the x-axis, y is always going to be 3. So y is 3 here, y is 3 here, y is 3 here, doesn't matter. So our line that is created is going to be a horizontal line because it is only going to travel up the y-axis and be connected in that way. Okay, I've had people say before that the y makes you think of an arrow going up and down. You can think of that if you'd like to. That's the way you travel, but I think this is a little confusing in the part that it is not the way that the line will go. Okay, little confusing with that. X equals -2. That means no matter what y is, I'm going to travel -2. So here I traveled -2 when y was 0. When y is 9, when y is 9, again, x is -2. When y is -5, x is -2. So that's going to create your vertical line, the line that goes up and down, because you're only going to worry about the point being measured on the x-axis. And that's in equations where there is only one variable, like y equals 3 or x equals -2. Now, another new term, we're going to talk about functions that we talked about in 8.1, but in a little bit different way. So in examples 3 and 4, the vertical line test showed that y equals 2x minus 1. All right. What we're going to do now is we are going to graph that to see if it is a function, right? The first thing we need to do is put this into function form. So when we put this into function form, we want to make sure that we have that y is going to equal something. Now why is that function form? Because remember, y is going to be our output, and the equation is going to be our input. We're going to put something into it, the x, and see what it makes happen for the y. Now, we started out with the equation 3x plus y equals 7. What we need to do, and I'm going to use my finger writing again here, is make sure that y is by itself or isolated, or we're solving for y. So we want that by itself, so we want to first of all go ahead and combine 3x with its opposite, -3x. If we do that on that side, we have to do on this side, balanced equation. I can hear you saying it yourself. And when we do that, we end up with our y all by itself equals, and I would go ahead and I would put the variable term first, -3x, and then 7 would be a positive 7. It's implied that that is positive. This is now in function form because we have our input as part of the equation and we have our output as what that solution is going to be. Once we do that, we can go ahead and we can go ahead and solve it for some variables. So let me, first of all, let's do finger writing again and change this equation into function form. Again, to change to function form, we want to get our y by itself. So here we're going to get rid of the x first by doing a -x on both sides, balanced equation. Cancels those out. We get that 2y is equal to, and again we want to put our variable first, -x plus 6. That's going to be our function form. And you can see that right here. I'm going to move this over here to on top of my input-output chart now, because our x is our input, what we're going to put into the equation to see what comes out. So I want to show you this one though and write it out. So we have, let's do one more thing and solve for y. I didn't see that this one did not have it that way. Okay, I need to divide both sides by y. I'm sorry, by 2. So 2 over 2 equals 1. So I have a single variable, 1y. Now, what am I going to do here? I have a negative x divided by 2. X does not have a coefficient, so it's an implied that it's a 1. So I actually have a negative 1/2 x plus, what's 6 divided by 2? Because remember, this is dividing this whole side by it. 6 divided by 2 is 3. That one's not quite as pretty as the one I typed, but we're going to go ahead and I'm going to see if I can copy that and put it by our input-output chart again. Let's see if we can get that whole group. Looks like I have it. Now, when I'm using that equation, again, input, let's input a negative 4 in here. What's negative half of negative 4? Negative half of negative 4 is a negative times a negative is a positive. Half of 4 is 2, so 2 plus 3 equals 5. So you see 5 as my output here. Let's skip down to 0. 0 is an easy one. Negative 1/2 times 0 is going to be 0. So in that case, y is going to be 3, the only thing that's left. Now I did the 4 in the negative set, so let's do the 2 in the positive set. A negative half of 2. Negative times a positive is going to be a negative, and half of 2 is 1. So we have negative 1. Negative 1 plus 3 would give me a positive 2. There is where I got my coordinate points. Moving that chart over to my grid, I can go ahead and graph this to see if it is truly a linear equation, but I didn't get any of my points wrong. Negative 4, let's come to the left, negative 4 on the x-axis, and let's go up 5 on the y. Negative 2, again, let's come left from the origin, negative 2, and we're going to go up to 4 this time. 0, 3 is my next point. I'm not going to move at all on the x-axis, but I am going to go up the y-axis to 3. 2, 2, I'm going to move positive 2 and move up 2. And my last one, 4, 0, 4, 1, I'm going to move over 4 and I'm going to move up 1. Now again, let's take our cloned little line here. Let's tilt it over and see if when I connect the dots, they do truly make a linear equation. Now the reason we're using a coordinate grid and we're graphing this way is that I could find many other answers to this equation by reading the coordinate points of different spots on my line graph. Let's see how accurate mine is. We have our dots just here moved a little. Let's see if 6, moving over 6, and up 0 would in fact be one of our solutions. So I'm going to go back to my equation equaling negative half of 6. 6 is positive, so that's going to be negative 3. Is negative 3 plus 3 0? It is, and it works here on the grid. So we're really graphing to see all of the possible different solutions that we can see on that grid. Moving on, oh, I guess that might be my very last slide. That is my last slide. So we talked about function form. Function is input-output, so you want to solve for your y, is you're going to substitute in input for your x and solve out what comes out of that, your y. We also talked about the rules if there's only one variable. If you only have y, it's going to be a horizontal line. If you only have an x variable, it's going to be a vertical line. And we talked about changing input-output charts into ordered pairs. The beginning started with giving us the ordered pair, and we had to check if it was a solution, and all we did was substitute our x and y to see if that was a true statement. So that is the end of 8.2.